How much gold have you got sitting in your desk drawer or perhaps up in your attic? Probably more than you might think, because a surprisingly large amount of the world's gold supply is tied up in old electronics. But getting it out is extremely tricky, meaning large amounts of the precious metal are actually ending up in landfill. Maybe not for much longer though, because researchers at the University of Edinburgh have developed a chemical solution to the problem, as Connie Orbach has been hearing from Jason Love.
In 1 tonne of waste electronics, there's about 300 grams of gold.
It seems a bit ridiculous that there's this amount of gold just sitting around. Why aren't we just scavenging it back? Why is it still sitting in those electronics?
If you think about the complexity of a mobile phone, there's lots of different metals in there. There's lots of plastics, and they all have to be separated. So lots of people are studying this, and companies are actually recovering the gold from mobile phones. But again, there has to be that economy of scale, and it has to be economic for that company to do that. And often it's much easier for them to just ignore it. So there has to be an economic driver. There's probably has to be governmental drivers to actually do this kind of work.
And you have come up with maybe a potential driver in that you might have made it a bit easier for everyone, right?
Yeah, that's right. So we've discovered a new reagent that can selectively recover gold from a mixture of all of the other metals in a mobile phone. And that's quite remarkable in some respects, because if you think about the amount of copper in that mixture, it's 8,000 times the amount that you have of gold.
So what do you mean by reagent, and how's it working?
The reagent is a common chemical. It's called an amide, and it's very simple. The way it works is we put the reagent into an oily solvent of some sort, and we dissolve the metals that are in the mobile phone in dilute acid, and then you can mix your oily solvent with the dilute acid, and your reagent then selectively extracts the gold from the acid phase into the oily phase. And then when you're finished, you just stop stirring, and the oily phase then sits on top of the water phase, just like oil and water don't mix. And that allows you to then separate out those two phases.
So you've got two sorts of solutions. You've got an oily one and an acidic one. And within your oily one, you've got this reagent which is selectively choosing the gold. And so when you mix them together, the oil pulls this gold out of the acid, and suddenly everything else is left in the acid but the gold. How's it doing it? Has it got lots of little men inside just pulling the gold out? What's going on?
You could view it like that, but it's not quite like that. What's happening is you're forming a compound in the oily layer that's very stable compared to the compounds that you have in the acid layer.
So it's more preferable.
Yes, absolutely. It's more preferable for the gold to be in the organic or the oily solvent rather than in the water solvent.
And at the end, I've got a load of oily gold. What do I do with that?
This is really one of the key parts of what we've been looking at, is what you do then is you've got your oily gold and then you mix it with fresh water. And then the gold actually transfers back into the water layer. And so then you have gold in water that you can then process further on.
So when we're doing all this, you said there's all these kind of things that get left in the acid, and I'm guessing some of these are quite important too. Why don't we want the other things?
There's a lot of copper, there's a lot of iron, and there's also things like silver and platinum and lead and tin. And whether they are recovered all depends on whether there's an economy for them. Countries like China have been flooding the market with copper, and that means the price of copper has really gone down. And so it can often not be economically sensible to recover that copper.
This process that you've brought up, you said it's very simple. How likely are we to see this being used now by governments and by maybe waste removal companies and people like this, so that we're actually getting back these valuable things in our mobile phones?
I think that's an interesting question, and we've had a few companies interact with us recently about this particular process. And the issue is that we're only looking at a very, very small part of the whole process. And so it will need a lot more investment and a lot more knowledge from engineers and economists to actually work out if it's going to be a viable process for gold recovery.
And so I'm guessing a lot of our listeners the same. I've got probably a couple of mobile phones at home. I've got an old tablet which is already defunct. How much money have I got sitting in my drawer?
If you have a few items, a few waste electronics, let's say there are 3, you will probably get a maximum of a gram of gold out of those. And so that's going to maybe earn you 10 quid or something like that. So actually not very much at all. And this is why you need to really have large amounts of mobile phones or large amounts of electronic waste and treat them all at the same time.
Well, I won't start raiding the cupboards just yet then. That was Jason Love commenting on his research, which came out this week in the chemistry journal Angavanti Chemie.